Okay, it's all you now.
Awesome. Okay, so I will share my screen in a second here, but just to follow up on that introduction, yeah, I'm a rising senior at Davidson, economics, computer science, major in economics, minor in computer science. Very passionate about data science, and I've been focusing on that now for about the last year, 10 to 12 months. I, like Chang said, I ended up getting involved in, bought a Expressive board, very similar to a Raspberry Pi or an Arduino board that you can connect sensors to and collect data. It's really a very cool opportunity that I didn't know much about until I got involved and heard about the opportunity. And I ended up turning it into a project where I collected data over an extended period of time, fed it into Google Sheets, and then built a machine learning model off of that data that does some pretty accurate predicting. So I will share my screen now. Let's see. How do I do, Shane, do you know how to do that?
I
Is
think
there,
there's a share screen, like a green button.
oh yeah, there we go. Got it. Cool. Okay. Great. Can everybody see that now?
Yep.
Yes.
Awesome. So, long story short, I took this beginning product idea of just building a sensor, building an expressive board that would then collect data and file it into Google Sheets. And I took that to the very end and then ended up building a website that kind of went over my process of collecting the data from just grabbing the data to begin with to then cleaning it, analyzing it, and turning it into models, and then building a system that would actually take user feedback and implement a prediction off of that. So to kind of start off with here, at the very beginning here, and I'll send this link after I'm done talking, but I linked to it, the data set. It's public and available for you all to check out. The uncleaned version, of course, so you guys can have fun cleaning it if you ever tried to mess around with it later. I also wrote an article about more extensively about the collection process and setting up the expressive board to work with the sensors correctly. And then I started off going over the pre-clean versus post-clean process. Here you can see I embedded the first 15 or so rows from the data set that's linked at the very top here. And I give an overview of what sensors I was using. So first it was a photoresistor, which measures the amount of light in the surrounding area. For example, with face recognition nowadays, it's actually a large part of that is the photoresistor that can measure like how your screen, how bright your screen is. It'll dim your screen automatically when it senses a certain amount of light in the area, and vice versa. So it's a really interesting small piece of a large amount of technology that Apple actually uses. The DHT sensor, which will report back the temperature and humidity in a room in degrees Celsius for the temperature. And lastly was a digital button, which would be on. The entire premise of this collection was that I would tap the button when I was in my room and turning my lights on, and it would change the amount of light in the room and potentially even the amount of how hot it was due to the light bulb in my room. And then when I would leave my room, I would turn it off. So it'd be reading 1 when it was on, 0 when it was off. And that was basically what I was going to be predicting on later down the road when I built the machine learning model. So to get further into the kind of the data that I was working with, you can see that we've got the date, just a simple event name, which is necessary for working with when I was reading the sensor data, just feeding it a name for each event that was occurring. Value 1, which you'll realize that these column names were not great, which was part of the initial cleaning process that I'll get into below here. But the first column, value 1, is a digital button. Value 2 is the photoresistor, and value 3 is actually comma separated temperature in Celsius and humidity readings. And you'll notice, interestingly, it took a little while for the in the rightmost column, you'll see that it took a little while for the humidity sensor to actually start. So that was an interesting thing that I had to incorporate into cleaning out the data. As you see here, when I say I overview what the kind of steps we had to take were, one was cleaning value 3, or cleaning the column names, which I then transferred into digital button, photoresistor, temperature, humidity. And then looking at value 3, this column here, I realized that we needed to figure out whether we should replace or remove those rows from the data set. I ended up deciding to remove them since I had over around 5,500 rows, and this was only a small fraction, just about 8 instances in my data set that I could just remove. It would not affect the model too heavily. Next, I ended up normalizing each column value, just dividing by the maximum value in that row for the photoresistor, temperature, and humidity. And last but not least, for the data cleaning, I decided to take these date columns here and extract the hour value. You can see like 08, so 8 p.m. all the way down. It went on and on because it was collecting data every minute. I decided to bucket those into hours and hot encode the data set and translate it. I had to build a little algorithm that would, one, just split the data and grab the hour correctly. And then I built a helper function that would check and see if it was a PM or an AM, and then just do the little mathematical addition, depending on what that value was. So you can see here, all these are zeros until you get to hour 20, which is 8 o'clock at night for the first couple of rows, which correlates nicely with what we see here with 8:50, 8:51, et cetera, up until 9 o'clock. And then it goes right over to 9 o'clock at night and continues for the data collection process. So that was the first big step in this project. It's broken into 3 parts. The next part that I'll show you over here is going into implementation, but I will pause for a second and see if anybody has any big questions that they want to ask it and get answers to before we dive too much deeper into this.
So Dan, what is the overall objective of the model? Ultimately, what are you trying to predict?
Yeah, so I wanted to keep track of when I was in my room or not with the digital button and see how that changed the light level in the room. Like, for instance, I would have the lights off when I was not there, or lights on when I was there. But then also, if I wasn't in my room during the day and I was at night, they might balance out in some level. So I was interested to see how good of a predictor that was of when I was in my room or not. And then I also incorporated the temperature and humidity as just other sensors to include in the model. But the big goal was just to use those 3 predicting feature values to predict on whether I was in my room or not with a digital button.
Okay.
Do you still have the device?
I do not connected anymore because I've been tinkering around a bit more with things, but I did include a picture. I put together a presentation that goes a little bit more into like the technologies that I used for every step of the way with like implementation code. So I'm going to send that after, and it's got a picture of the little setup that I had. So I will include that so you guys can check out what that looked like.
Hey Dan, just a quick question. So how is this data collected? Do you use Raspberry Pi, or is there any? I'm sorry, I was late to the meeting.
That's okay. Yeah, so I was very similar to Raspberry Pi. I used an Expressive board. ESP8266 was the specific model. And I just had to connect the sensors with the wires correctly and then plug it into a power source. And it would automatically collect. I set up the code so that it would run every single minute. It would read a new value and send it to a Google Sheet.
Oh, okay, got it. Thanks.
I have a question.
Mm-hmm.
So in terms of your data, you have over 5,000 sample data, and then you have 28 columns because you create the hot encoding. So the hour, there's 24 columns. So would that be like sparse to create some issue when you train your model? Too sparse?
In terms of what? In terms of like the speed of the model, or like
the accuracy, because it's 28 column, and would it be like not enough data sample observations?
Yes and no. I mean, the data that I collected was fairly linearly separable, and I ended up using, which I'll discuss a little bit next. I used two different models. First, a support vector classifier, which is really just looking for the, you know, whether it's a hard margin or soft margin, if it can maximize the distance from the decision boundary to the nearest data points from each class. And that was relatively simple for it to do, given that there weren't too many outliers. The data was pretty easily classifiable with a linear model. So that was a big part of it. Obviously, yeah, it's not a ton of data considering a typical machine learning model, but also considering that it was a project, a side project that I ran for from like November, the last week of November, then took a break for winter break or pre-finals, and then put it on for the next 3 weeks after that. So it was a decent amount of time, and then I came back home and decided to build up the actual like post collection project.
I see. Thank you.
Hey, Dan, the photoresistor value, so is it going from, what is the range? Is it going from 0 to 1?
Yeah, because it was normalized. You'll see up here that the maximum value would have been, let's see, do we have a max? Looks like it was row 23, which isn't going to be shown up here, but it ranges. You can see some of the values here, like in column value 2 here. You can see these were the initial values, and then I ended up just normalizing them between 0 and 1 down here. And this is like the maximum value would be 1, the minimum would be less than 1. So it'd be between 0 and 1.
0 would be complete dark, right?
Yes, I think so. Actually, I think it would be the other way around, because the higher that the light value is, the less, I think, the less resistance. It's something weird there. There's like a little, it's kind of the opposite of what you would think. Yeah. Any other questions, or can we move on?
Mike asked a question in the chat, so I'll read it. Yeah, Mike asked, Dan, what were you using in backend? For example, time series database to capture your data. You have a spreadsheet. Any need or wish for a database interface to make updates or queries? Did you just export to CSV spreadsheet, or was it collected in that form?
Yeah, great questions. So I read it in from just the Google Sheets API. One thing that I could have done was just read it in from the CSV, and I could have set up more of an official database, but I used If This Then That, which is a nice service that easily integrates with Google Drive and Google Sheets when you're working with like sensor data, like an Arduino or a Raspberry Pi. So it was super easy to set up. So it would have been cool to use like a MySQL database, but it might have been a little bit of overkill given how there were easier ways to go about things.
So Mike,
a quick question, how long did it take to clean the data?
Well, I would say like renaming the columns was easy. That's like my first step when I do anything, is like I'll remove spaces and replace them with like underscores and like rename the data of the columns to be representative. But then like getting a better feel for cleaning, what I would need to do for like normalization and things, was kind of just like a process of like messing around. So it was really probably just a couple of hours, because I had good control over how the data was being read in from the sensors, because I kind of deliberately set it up to be a pretty easy cleaning process. But there were some things that threw me some curveballs, like one hot encoding took a little while with the date. That was probably the hardest part.
All right, thank you.
Shang, were you going to say something?
No, I was just say that because Mike's follow-up question was, before you answer, he was asking if you were using IFTTT, and then you said that's what you're using. Yeah,
IFTTT was very helpful. It's a little bit of a learning curve for all that stuff when you're just getting started, but it's worth just putting the time in to kind of understand how things work. So it was a good experience on that, on the data collection process. Okay, so now briefly cover part 2 of 3. My biggest thing when I'm looking to build a machine learning model, sometimes I see a lot nowadays, like companies and people specifically will just try to overcomplicate it and look for like what the newest thing is and the coolest way to build a model. And I think that I really tried to focus on like building up an intuition for like what actually makes sense here. What stating the assumptions was the big first step for me. So looking at what those basic assumptions are for a k-nearest neighbors model, and then a support vector classifier. Those were big things that helped me kind of determine that, okay, obviously I'm working with a supervised training data set. I have the correct labels, so I'm going to work backwards from that. And then it came down to using a binary classification system because it was 0 or 1. Am I in my room or am I not? And that was really what led me to make these decisions to, one, I think the best, my initial hypothesis was that going for the support vector classifier made a lot of sense and was going to give me great results. And I started with that, and then I just ended up adding in the k-nearest neighbors later on to see how that kind of like a model worked with the system. So you can see that I kind of just broke this page down into whether it was k-nearest neighbors or a support vector model. And then I go over some of the mathy stuff that we don't have to dive into too much here, but the overview is that each model has a set of parameters that will have to be tuned and can be tuned through hyperparameter tuning, which is a whole sort of process that goes into building out a model that can sustain itself over time. And I did a little bit of research to try to understand more of how these things work, why I would choose one metric over a different one for like measuring the distance and things like that. And that just led me to kind of want to include some of the mathy stuff behind what I was doing. And so here you're going to see different distance metrics and measurements that I included. But the more fun stuff is down here. You can choose your parameters, which I give you the option of choosing some of the more popular important parameters to choose for the k-nearest neighbors model. I also give you the option to run a grid search, which will take a little while, but I'll demonstrate just for the purpose of demoing. It'll take a little while because it's going through a combination of different parameters to see which ones lead to the highest accuracy. I use the grid search I base the grid search off of how high the accuracy was. So I was using just the score of how many times it correctly predicted the model versus how many times it incorrectly predicted the model to determine what the best set of parameters were. So let's see, great, there we go. So then it renders a nice little table here that says, okay, so auto is the best algorithm to use to compute the nearest neighbor, use 5 neighbors, and use distance for the weight function. And if I do that, let's see, 5 and auto, you'll see here, it will compute and return the accuracy of the model. So 99% accuracy. And then it'll also render the confusion matrix, which is a great metric to use to calculate the false positive and true positive rates within a classification model. For example, here in the top left, this is your true positive. And then in the bottom right is your true negative. And then this is your false negative in the top right. Bottom left is going to be your false positives. And one of the great things about this is that it really forces you to build out an intuition behind your model. You really want to think about like what is in this scenario like a false positive. Like it's saying that I'm in my room when I'm not. That really doesn't matter. So having a couple of those is not a huge deal. But if it's a situation where somebody it's saying that somebody had like fraudulent activity on their account and they didn't, then you can see how the intuition becomes like the very important component to using this metric to determine an action or whether to use the model. So that was a big part of like me determining how good my model actually was. And then just to give it more of a visualization appeal, visual appeal, I built this kind of just a heat map that shows you different values and how high they were. So you can see like the highest heat correlates with like a yellow and then like the pinkish color. And I also build out some other visuals. One thing I like to do with the k-nearest neighbors is look at the accuracy versus a different number of neighbors. I just chose arbitrary ones between 5, 10, 15, 20, 25. And you can see how the accuracy of the model performs over time there. And then last but not least, I went with the receiver operating characteristic curve. It basically plots the true positive rate versus the false positive rate. You can see on the y-axis here. And you draw a 45-degree line, which basically denotes that your model, if you're along that line, it is no better than just random guessing. It's between, like, it's just gonna randomly guess. But the closer that this purple curve is to the top left, means that it's got a higher true positive rate versus the false positive rate, because it's pushing the false positive rate closer to 0 and pushing the true positive rate closer towards 1, which would be 100% true positive. So another very valuable way to check out how well your model is doing with a different metric. And I basically broke that down and did very similar stuff for the support vector classifier. I went over some of the math again here, and then different parameters you can choose. And lastly, I broke it down once again with the confusion matrix, the test accuracy versus the different kernel, and then the ROC curve. So I can dive into that if you guys want to see what those look like, but it's basically the same plotting. I did end up using a bar chart instead of a line chart for the test accuracy this time, just with the different heat numbers, but they're all very close. So it's can be kind of misleading. You want to see that the range is really between 0.87 and 0.91. But yeah, so once again, this is part 2, and happy to answer any questions before we kind of move into part 3, the final part where it'll actually accept new instances and calculate the value based off of that.
So Dan, in order to do this, so you use the Raspberry Pi. So do you need to have any special hardware knowledge, or is it all standard? You really don't need to have anything specific in terms of hardware knowledge.
I did have to learn some things to get started, mostly with C++, because I don't know C++. I just kind of realized that it's what people use to interact with Arduino and Raspberry Pis and ESP boards. But the great thing is that it's probably one of the strongest developer communities. It's definitely up there, I would say. There's a ton of great websites, some of which I linked to in my actual presentation that I'll send you guys later. But other than that, there's a lot of starter code pretty much for any sensor that you want to connect. There'll be code to show you how to get that up and running. And that right there is very helpful. It gives you a good boost of confidence to give it a shot and to keep trying.
Okay.
Quick question. So did you build this colorful confusion matrix like from scratch, or there's like a framework for you to follow?
Yeah, so in the top here, I don't know if you can see my, well, I could probably highlight. Yeah, so you can just see what I'm highlighting here in the top left. That's just in Pandas. There's a built-in method that will calculate this for you, and it'll render it as a matrix, as a 2x2 matrix. I forget what it's called off the top of my head. It's not confusion matrix, but it's something similar. And if you Google like confusion matrix with Pandas, it'll return exactly what I'm thinking of. But then I use those numbers in the matrix here to build a heat map with Seaborn, just 2x2. And the other thing you could do is that scikit-learn has a built-in confusion matrix method that will just take the true y's, the actual answers for your data, the actual y values, and then the y predictions. And if you feed them in, it'll look at true positive, false positive, et cetera, and build this out for you, which is also really cool.
Yeah, it's cool. Thank you.
Hey Dan, Krishna here again. So is this confusion matrix built with test train data, or have you tested this with real-time data once the model accuracy has been established and has been deployed?
Yeah, so I split my data set 70-30. So training data was 70%, testing data was 30%. And then I've also built it off of using some of the data that I collected, looking at trying to actually like input values in this part 3 that I'll show you, where you can put in new instances. So I guess to answer your question more specifically, I guess, yeah, like I split my data into training and test sets, and followed best practices to the best of my ability as an undergrad machine learning engineer, to follow what I should and shouldn't do to build out the best, the model that generalizes the best across the training and test set.
Thank you. Yeah, we're all learning, so it's good.
Exactly. Yeah, it's a lifelong thing, right? It takes a long time.
Yeah, I agree.
All right. Anybody else have any questions before we go on to part 3?
I have a question.
Okay. Yeah, I'll read Mike's later. Ying, you can
Okay.
go.
Okay, so I'm asking about like hyperparameter tuning. So it seems that there's like a, you are not really like tuning hyperparameters using like in the tool, right?
Yeah, I was just running a grid search here to run some combinations of different parameters, to choose the best ones for the model.
Yeah, because I think there are like many tools that we can use to like tune the models.
There is have you heard of H2O?
Yes, I have heard of that. Never used it.
Okay, H2O is incredible. And I've used it for another model that I was building, and very useful. I mean, you just feed your data in and it handles everything for you. So it really requires little effort on your front to get started with them. You have to learn some of the syntax because it's kind of like its own little language, but it's all Python syntax, and it requires very little cleaning and structuring of the data before you push it in. And then it'll give you like a top 5 list of like, here's one model, here's the next model, like, and this one performed the best accuracy, XYZ. So that's a really good tool that I think can remove a lot of friction from like getting to, okay, I've got data, what model do I want to use, to like actually building with that model.
Cool, Ray, thanks.
I'll read Mike's question from the chat. Dan, did you do a Bayesian analysis with each sensor and group of sensors? Did any one sensor input predominate in correlating with your presence? Light may be a giveaway unless you added a chaos monkey which turned lights on off without you, right? Humidity and temperature may be hard to fake.
Yeah, so I did not run a Bayesian analysis for each group, but what I did do was I looked at the class balance between when I was in my room and when I wasn't, to make sure that there was a decent ratio between how much data was actually rendering when I was in my room and when I wasn't. Because obviously that's one of the biggest things to be concerned about when you're running with a classification model, is you want to make sure that your classes are balanced across the board. So for me, it was just looking at when I was in my room and when I wasn't. Fortunately, I bounced back and forth quite a bit throughout the day. So I had a fair amount of, the balance was good. I want to say it was like 40-60 or 45-55, which is pretty good. I was happy with that, just because given that I was working with not a huge amount of data, that was important to have that balance across. Light may be a giveaway. Yes, it was, but I also always had my window open. So I figured that it would be interesting to just kind of like, because I'm not a hardcore statistician, being an undergrad and having stats background, but also not a graduate degree. I think that when I was like building out the actual collection process and like the experiment, I was thinking that I'm just going to hold a lot of things constant where I can, and just maintain uniformity across the experiment, so that it would, if something is affecting it in an odd way, it'll at least be standard throughout the entire experiment. No, it was actually because the model was pretty accurate. There were some times where I think it would, because my schedule would change, especially because I was collecting data through finals. I do think that could have skewed the model a little bit because my time of being in my room was pushed back a bit. But to be honest, I did not really dig into like when it was saying that I was there and wasn't, as much as I just kind of looked at the true versus the predicted values and looked at more of the numbers around that instead of like the actual instances where things were wrong. That is a good point, though. That is something that would be interesting to look more into. All right, any other questions, or can we move on to part 3? All right, looks like we are good to go. So this will be a little quicker, but this is just the final part that I wanted to build out was allowing users or people, myself even, to come back and put in actual values for the data to then render a prediction on that data. So getting new instances for the data set and seeing how accurate it was. Obviously, testing it's a little hard because you have to kind of base it off of example data from the data set, since like nobody knows what the photoresistor value would be of like when they are actually there or not there. So it's a little counterintuitive to like what a usual model might be working with, but given what I was building out and given the experimental setting, it was something that I wanted to allow, you know, myself and others to kind of interact with and see what it looked like to build a dynamic model that could take in new data and actually build predictions off of that. So you can see here, I provide examples. I believe I just took maybe the mean value or something along those lines for the different inputs. One thing that was a little bit of a challenge, which was an interesting design for me, was obviously we had one-hot encoded the data set. And so I had to figure out like the easiest way to maintain, like to input the correct value for one in the column that it corresponded with for the hour, and have every other one 0. So I was trying to be creative about that. Looking back in hindsight, it's not very tricky, but it was something that I was thinking like, that's a really interesting design principle to build off of, like thinking how you're going to have more columns than inputs normally if you're one-hot encoding or something like that. And you have to think about how to incorporate that into when you're actually building the prediction part of your model. So that was fun. I will show you here just based off of what kind of data is already in here. You could choose an hour. Let's say it's 8 o'clock in the morning, and we can run this with k-nearest neighbors, and it'll run and predict that I was in my room. And then if I go back here and let's say we go like, maybe let's try 4 p.m. There you go. So then you can mess around with these values a lot. Let's see if I make it a little bit higher here. This could change things. Yeah, so you could really just play around with this a lot, but this was the final part of the project, and it was a good amount of time that it took to put everything together. I will touch a little bit on now choosing Streamlit versus Flask for the deployment, because that's a hot topic that I've seen a lot of people discussing in the Python community lately. Streamlit's really cool, and it was really easy to put together a user interface. The way that I break it down, I think Streamlit is a great way to quickly deploy like an internal tool or something that you're going to be using for a presentation, maybe within the company you work for. And I think a Flask maybe has more of a robust way to render different templates and have more control over that user interface that can provide more flexibility in like a customer facing product. If you're deploying with Python, of course. There's also a ton of other ways to do things, and that all gets very tricky very fast, choosing the right way to go about it. But within a Python world, I would say Streamlit is great, and you can see that there's not a ton of customization for the user interface, the coloring and the design, but there is a lot of flexibility in the inputs and actually grabbing user data and building nice plots and all that stuff. So open up to any other questions. If you guys want to see me do anything else with this page, or just have an open-ended conversation about this, we've got 20 or so minutes, I guess, Chang, so we can do whatever you feel is best to wrap up the discussion.
Yeah, I got a quick question. So what percentage of your results were 1 and what percentage of your results were 0 on average? I mean, if you have an estimate for that.
Yeah, so that would go back to the classification balance that I was talking about a little bit earlier. It was one of the first things that I looked at, because in a classification model, it's really important. And so in the actual values from the data that I collected, it was about 45-55 balance. 45 being when I was not in my room, and 55 being when I was. Then the predictions would just be a fraction of that based off of the accuracy. So it would just, right, because it's just it's 98% accurate or so, so there would be some flexibility around how many were predicted to be which, but it would still be around that same 40 to 60% ratio.
Do you think if you collect more data, you can somehow interpolate and figure out how long someone has been in the room or how long they've been out of that room, and if it's 5 minutes by looking at your photoresistor numbers and temperature values?
Yeah, so I think that's kind of already baked into the data I have, just because it's going to be 0 when they're not. In a perfect setting where like it's always 0 when like they remember to turn the button off when they leave, then I've got that data already. So yeah, that's already kind of there. But obviously I would expect the model to generalize better across more data, just because that's, you know, the great definition of machine learning that I've heard is like, you've got some performance metric P and you have experience E, and as time, you know, goes along, as experience increases, that performance metric should become better, whether it's maximizing or minimizing, whatever that metric is, it should reflect that the model is getting better. So yeah, you would assume, it would make a safe assumption to say that it would get better at predicting what it's built to predict. And some of that data is already baked in, yeah.
Okay. All right, that's really cool, man. Good effort.
Thanks, thank you.
Yeah, this is a new perspective to me. I've never done IoT projects and machine learning models on top of it. So good job, Dan.
Thank you. Yeah, I would encourage you, you know, the ESP boards are like $7. It's crazy. I mean, like Raspberry Pis are more expensive. Arduinos are like 40 to 50. And then now you've got NVIDIA that's got like these like machine, you know, like full out machine learning boards that can do unreal things computationally. But, you know, you could start cheap and really get moving with about $25 worth of materials if you bargain hunt across like Amazon and different e-commerce sites. So it's a really cool experience to see something from a different perspective. Yeah.
Hey, Dan, can you remind me during which months you collected the training data?
Yeah, so this was in the end of November. And then there was a gap when we had a break before finals that we were all off campus, and I wasn't, you know, I didn't bring it with me. I just left it there to maintain that uniformity and just I unplugged it from its power source. And then I plugged it back in when I got back to campus for 3.5 weeks in December. So it was about 4 weeks or so of data.
Okay.
Hey, Dan, I wanted to ask a question. So in the introduction, you mentioned that you're into cybersecurity. So what sort of projects you see like implementing IoT in that?
Well, that's a great question. That's a great question. I think that the entire industry as a whole has a lot to figure out there, especially in a world where remote working is rising. And if that trend continues, then I would say it's something to be on the lookout for, IoT applications in the cybersecurity space. Off the top of my head, I don't specifically know an application, but I would say that it's going to be increasingly important for people to be able to track certain things if they're working from home. And I just read something today about like dual authentication. and how they've seen incredible usage numbers across the last couple of months, and the importance of just like having a private network set up and having dual authentication, things like that. I think that if you continue to look at that space, you'll see adjacent communities that start building in different ways. So I don't directly know, but I would say that because the space that I work in is mostly, we have a massive database of darknet and deep web data. So I don't necessarily know what the trends are. I know more about the trends of the people hacking and doing illegal things on the darknet than I do about what kind of implications there are for the future of the space. Yeah.
But Dan, you know, if you are asked the same question, but then we are not talking about cybersecurity in general, taking the whole, what could be the real world applications for something like what you just showed?
Like the IoT plus machine learning kind of thing?
Yeah, like,
Yeah.
you know, using, pulling the data from different sensors and then using the models to predict. Just whatever you have done, the core theme of this your project, what are the, in general, what are the real world applications you are thinking of?
Yeah, one of the biggest things that I've seen, and I know has been around for quite some time now, is automation within warehouses. And taking in sensor data there is obviously one of the most important things that they do when they're detecting anomalies or novelties. It's two subsets of machine learning, novelties being completely new circumstances, things that have not been seen before, an instance where the sensor is reading something that has not been seen before by the model, and then an anomaly being like an outlier determined by some threshold that might have happened a couple of times, or the anomaly can be detected several times, but it might denote like a faulty manufacturing, or something important for people to say, oh, like maybe you're manufacturing envelopes and like it's cutting the edge like just a bit too far off, and that edge is increasingly getting further away, and sooner rather than later you're thousands of dollars down in inventory because you had an inventory mistake in manufacturing. And I think that is a really important thing where like cutting the feedback loop from reading in sensor data to executing a decision based off of an anomaly or something like that is going to be a great application space. It has been around for some time, and it's been really important for these autonomous manufacturing vehicles like Amazon and Apple and all that kind of stuff. But I think that the tighter you get that feedback loop and the more confidence you build up in the technology, the implications grow exponentially.
Yeah, I can provide an example of the project that we are currently working on. So I was working for a client where he has manufacturing plants across the globe, and he has conveyors, right? Every manufacturing plant will have conveyors, and those conveyors run on some. So whenever there is an increase in vibration, so we're going to predict when the maintenance of that conveyor might occur, and we do advance pre-maintenance before it even breaks down. So we're taking different sorts of data, like what sort of load has been gone through that conveyor per a day, and like vibrations is another parameter that we are considering. So it's just an example. That's just one bit of projects that we're doing. In general, machine learning on manufacturing with IoT has huge possibilities.
Yeah, that's great. Thank you for adding that. Yeah, I think that's what excites me the most is the anomaly detection and novelty detection. But I think there are so many implications out there as the ability for models to generalize gets better. Things, like I said, increase exponentially, and that'll be the biggest challenge throughout the next 5 to 10 years.
Yeah, so right now industry is in a phase where they're trying to figure out where can the models can be implemented. And in most of the industries like finance domain, I could see it's already matured, but manufacturing is where it's just started, I believe. And it will go exponentially for sure.
Even reinforcement learning is another one. I saw today that Boston Dynamics began opening up their most popular robot for like $75,000. Steep price point, but stuff like that, you know, that's going to be increasingly interesting in a manufacturing setting and other places too, especially if we have a more distant, socially distanced world. But a lot of hypotheses, you know, we'll see.
Dan, are you able are you able to see the Mike's message in the group chat?
Yeah, I have it pulled up. One, yeah, absolutely.
Sorry,
Some of them are much.
So could you mind read the question for the recording before you answer it?
Sure, yeah. So did I code the interface IFTTT from the ESP2866 or through RPI on the same Wi-Fi? I'm not sure what RPI is, but I did use, I interfaced with IFTTT and set up the Google Drive through, it was all through ESP8266. You just get like a unique key, kind of like an API, and just interface through there, from what I remember. Raspberry Pi, yeah, I wasn't using Raspberry Pi, sorry, yeah. Let's see, what else? Yeah, okay, great. Can I go direct from the sensor to, yeah, exactly. So I went direct from the sensor, and yeah, it is very inexpensive. That was one of the greatest parts about this, was it's very cheap to get started. Just getting the board, like Mike said, can be even cheaper than $7. And getting some of the connectors and the sensors and all that stuff is pretty awesome, pretty cheap.
I have a question. What is the most challenging part for you in this whole project?
That's a great question. Well, one of the most challenging things that I think many machine learning projects present for anybody, whether it's in an enterprise setting or just a personal project, I think is learning that the importance of stating assumptions from the beginning. This is what I preach, because I think that people fail to do it quite a bit. And I really think that in any data science setting, any like machine learning, data science, whatever it is, any data role, you need to start from the assumptions and break the problem down into what the fundamental truths are, and then build up from there. And it might sound like overkill in a personal project that is like very, you know, just like a fun thing to do. But I think that, you know, you got to practice what you preach. And for me, that took a lot of time to really sit back and like break those things down. It's a lot of work mentally to like think through the model of like, okay, what, you know, what is going on here? How is this distributed? Like, is it linearly separable? And like just inspecting things and making sure that what I'm doing is actually can be backed up in an argument. Any other questions?
Okay, if we don't have any more questions, can everybody unmute in 5, 4, 3, 2, 1, and then we'll give Dan a round of applause. Thank you, Dan.
Great job, Dan.
Thank you. Thank you for
Really
having
cool.
me.
Great job.
Great, thanks.
Yeah.
Thank you.
Yeah. Okay, so someone asked, Dan, what is your email address?
Yes, yeah, it is. Well, let me send it in here, and all of my information will also be in the slide deck that I'm going to send in the general channel. Let me see, Dan. Yeah, that's correct. So there's my email, but you'll also have my GitHub, the link to this actual web page, my email, and then you can always reach me on Slack as well. But I'm 100% responsive. So please, would love to hear feedback, recommendations, critiques, everything. I would love to get in touch and talk more about machine learning.
Thank you. I guess that's all. If anyone who is new to our group and you don't have access to the Slack channel, please message me on meetup.com. I can help you out, because we change a little bit how we're joining these days, so it might be harder to find.
Yeah, I remember coming to one of you guys' sessions in Charlotte at the Google Fiber office. This is a few years ago. You guys were talking about chatbots back then. So I'm not sure if I'm still in the Slack group, but I'll have to check.
Okay. Thanks, everyone. We'll see. We'll let you know when our next talk will be. And feel free, if you have an idea, feel free to showcase your project. We love it.
Sounds great. Thank you.
Thank
Thank you,
you.
Dan. Thank you, Chan.
Thank you. Bye.
Bye.
Bye.